In today's assignment, we're going to continue talking about slope. So in our previous assignment, we said the word slope is always represented by little m. Anytime we see little m, we should know it means slope. We also said that slope is known as rise over the run. Okay, what's our rise over our run? All right. So in the previous lesson, we had if our slope was going up, the line's headed up, we should end up with a positive slope. If our line was headed down to the right, it has a negative slope. And in Mrs. Brimhall's review assignment, we introduced the concept that if we had a flat line, a horizontal line, it has zero slope. Okay? And if you think back to when we first talked about this with the houses, right? In the Park City house, the Ogden house, and the Arizona house. The Arizona house has a slope of 0 because it doesn't need any snow runoff, right? So that's possible. We can have 0 for slope. All right. Today, though, we're going to look at slope as another way. We're going to look at slope as being the change in y over our change in x. Okay, but that's too much to write. Change in y over change in x. So math people, we just call this triangle y over triangle x. And when I was in junior high, that made no sense to me. I'm like, huh? Triangle y over triangle x? What does that mean? Well, it really just means delta y over delta x. But that still makes no sense because I'm like, why are you talking about delta y over delta x? It's just a shortcut for change in y over change in x. So it really just means change in y, change in x. Okay, and this will make sense as we get going. So today's lesson, we're going to build off of what we've been doing. So let's say I give you a t-chart, and I give you some values of 1, 2, 3, 3, and 5, 4. So in a t-chart, we know the first values listed are always my x values. The second values listed are always my y values. So really, in my table of values here, I've given you 3 ordered pairs. So we have the ordered pair of 1, 2, the ordered pair of 3, 3, and the ordered pair of 5, 4. Okay, so there's 3 ordered pairs. And the whole goal is, I want to know what is the slope, like we did before, for these pair of points. So I could graph these and get a picture like we did in the previous assignment. So if I graph the 3 ordered pairs given to me, 1, 2, 1, 2, we know that my x value is at 1 and my y value is up at 2. So we're right 1 and we're up at 2. And there's my point. My second ordered pair is at 3, 3. So that means go right 3 to x and go up 3. And then there's my second point. And my third ordered pair is at 5, 4. So right 5 on x, up to 4, and there's my last point. And if I send a line through these, my graph should look something like this. So if I notice it is going up, like this picture, so when I get done, I better have a positive slope. Okay? And then we could do what we did before. We could say, hey, we got all these points here. So let's say we got a little dude and a little guy standing right here. And he wants to go from this point to that point. So what is his rise over his run? So from here, he has to go up how much to get to that point? He has to rise up 1 time. And going up 1 is a positive. And then he has to run to the right or to the left. He's going to run to the right. And if we count our spots over, he went over once, he went over twice. So he has a run of 2. So our slope is 1 over 2. And if we check that and we go again from here to this point, we should get the same thing. So I go up 1, and I go right 1, 2, and there I am again. Up 1, right 2. Up 1, right 2. And if I try it again, go up 1, and go right 2, I should still be on the line. And we really said that slope is like kind of building stairs, right? But the slope in this case is 1 over 2. And that's the answer for this problem. But there's got to be an easier way. I don't want to always have to draw a graph picture to find the slope of a table. So let's look at another way we can do this. If I give you a table and I say you have -2, 1, 0, 4, and 2, 7. So once again, I've given you 3 ordered pairs. We could graph this like we did here and find the slope using rise over run. But we're going to do it the new way today. We're going to go do it change in y over our change in x. Okay? So once again, we know the first ordered pairs are our x's and the second numbers listed are our y's. So what do we mean by change in y over change in x? So here's the y's. This is where you got to be careful. That's where kids make mistakes. Y has to go on top. So if I look, what is happening from 1 to 4? What is the change? From 1 to 4, I am adding 3. Well, what's happening from 4 to 7? I am adding 3. So my change in the y side is a positive 3. And on the x side, what's happening over here? If I'm going from -2 to 0, I'm working my way out of the hole. I am adding 2. And if I went from 0 to 2, I'm getting bigger. I'm adding 2. So the change in y was 3. The change in x is 2. So there's my slope. I'm adding 3. Then I'm adding 2. Okay, change in y over change in x. If we have another table, and we have 1, 5, 2, 3, 3, 1. We know these are our x's, these are our y's. So what's our change in y over our change in x here? We're going from 5 to 3. And then 3 to 1. We're not adding, we're getting smaller. We're actually taking away 2. We're taking away 2 each time. So our change in y is a -2. And what's happening on the x side? From 1 to 2 and 2 to 3, we are adding 1 each time. So that's a positive 1 still. So our slope is -2 over 1. So that picture, if I did graph it, would look something like this. The line would be going down because it has a negative slope. Okay? So you can just simply do change in y over change in x to find these. So let's give you this one. 4, 10, 6, 7, 8, 4, 10, 1. These are our x's, these are our y's, right? I want you guys to do what's the change in y over the change in x. The change in y from 10 to 7 is minusing 3. From 7 to 4, we're minusing 3. From 4 to 1, we're minusing 3. So our change in y is -3. What's happening on the x side? We're going from 4 to 6, 6 to 8, 8 to 10. So over here, we're getting bigger each time. So from 4 to 6, what do? We added 2. From 6 to 8, we added 2. From 8 to 10, we added 2. So our change in x is a positive 2. So our slope is -3 over 2. Okay? Now a great question came up the other day in my honors class when they were doing this online. Now, it looks like a fraction and it's top heavy, right? So I had an honors kid ask me like, hey, it's 3 over 2. Should I make this 1 and 1/2? No. Slope is a change in y over a change in x, or a rise over a run. So it looks like a fraction, but no, it means something different. We want to just keep it what it is. Okay, so even this one, If it looks like it's top heavy, just leave it like it is. Okay? Now there's another thing I want to point out to you. I see the changes from here is 10 to 7 is negative 3. From 7 to 4 is negative 3. From 4 to 1 is negative 3. Do I need to do it in every spot? Do I need to do this over here on every spot? No. Okay? We said this was, slope was like building stairs, right? Think about your stairs. Your stairs are a constant. Your stairs always look the same. You never go climb up a staircase and have your stairs look like this. Here comes your first stair. Here comes your second stair. And then all of a sudden, here's your third stair. And then here's your fourth stair. And then here's your fifth stair. And then your sixth. And then there's your seventh, right? That would be kind of a weird set of stairs to have to climb, right? Those are not constant. Your stairs are always the same. Same rise, same run. Same rise, same run. Same rise, same run. They look the same, okay? Think about when you climb stairs. So over here, once you see that it's a change of negative 3, you're good. Once you see it over here, positive 2, it's good. So what do I mean by that? If we have 3, 7, 2, 3, 1, negative 1. These are our x's, these are our y's, right? So we want to find our slope again. Okay, so I'm right here, I'm getting smaller, right? I can see that. And from 3 to negative 1, some kids don't like going from a positive to a negative. Okay, that's tough for them to see. So why find it here? Just go to a spot you can see. From 7 to 3, I know what I'm doing. From 7 to 3, I'm getting smaller. And how much am I taking away? I'm subtracting 4. I don't need to worry about this. I know that that's going to be subtracting 4. It's constant. So I know it's negative 4. I don't have to do it in one spot. Over here, what's happening? Well, from 3 to 2, I'm getting smaller. I'm taking away 1. I don't need to do it in the next one. I already know the answer. It's negative 1. So it's negative 1. But wait. Let's clean this up. Negative divided by a negative really makes a positive. So my slope is 4 over 1. Okay? So that's how we find slope from a table. Now what happens if they do this to you? And they give you a point and another point. And they say, I want to find the slope of just the distance between these 2 points. Okay, well I could make a graph, right? I could do that again. And I could graph the ordered pair 4, 1, which means go right 4 and go up to 1. And then 7, 8, go right 5, 6, 7, and then clear up to 8. 2, 3, 4, 5, 6, 7, 8. So right here. And then draw a line. And then do my rise over my run and build my staircase, right? Build my little triangle there. But I don't want to do all this. That's too much work. Couldn't I just make a quick little mini table like we've just been doing? In an ordered pair, we know the first value is the x and the second is the y. We know this is the x and this is the y. So couldn't we just put those values in here? So the x is 4, the y is 1. The x is 7, the y is 8. Okay? 4, 1, 7, 8. And then just do our change in y over change in x. From 1 to 8, we're getting bigger, we're adding 7. So positive 7. And from 4 to 7, we're getting bigger, we're adding 3. So positive 3. Positive over positive is still a positive, and our slope is simply 7 over 3. And we're done. Remember, keep it improper, right? Don't make this 2 1/3, right? Our slope means going up 7, right 3. Up 7, right 3. Up 7, right 3. Okay? So our stairs are consistent. They're really steep. It's a big, steep line, right? But that's okay. And we're done. So let's say we have the ordered pairs of 5, 2 and -1, 4. I'm just going to simply make a T-chart real quick. 5, 2 like that. -1, 4 like that. And do our change in Y. From 2 to 4 we are adding 2. So positive 2. And from 5 to -1, what's going on there? Think about it. We're getting smaller. We pass 0, so from 5 to 0, 0, 5 spots, and 0 to 1 is another 1 spot, so we went down 6 spots. So our slope is 2 over -6. Okay, now both Miss Brimhall and I have talked about you got to be careful. If you can reduce the fraction, though, you should reduce it. So 2 over -6 reduces down to -1/3. Okay? And notice, I moved the negative from the bottom to the top. It doesn't matter. Okay? I don't care if you put the negative on the top or the bottom. It's still the same thing. There's one negative, just getting in there. Okay? Alright. You guys quickly do this one. 4, 1, 7, 8. Make a little table. Find your slope. Oh, I lied. We already did that one. Bag that one. Do this one. 2, 5 and -1, 5. There you go. Make your little table. Find the slope. So hopefully you put a 2 there, 5 there, -1, 5 there. Okay, I tried to trick you up. Change from 5 to 5 is 0. We didn't do anything. We didn't go up or down. From 2 to -1, we got smaller. We went down by 3. So remember, it's change in Y over change in X, -3. So our slope is 0 -3. So what does that mean? 0 divided by anything is always 0. We get a big whopping 0. My answer is 0. So what does that mean that the slope is 0? Let's go back and look at this in picture form. So if I graph him right here on the side, 2, 5 means go right 2 and then go up to 5. And -1, 5 means go back 1 and go up to 5. Send a line through them. Oh, what do we get? The one that Mrs. Brimhall talked about with her skier, right? If you start here, you have to go up or down nothing. You have a rise of 0, but you have a run of 3 times, either to the left or to the right. But your slope is 0, right? It's that Arizona rooftop. You can have a house that looks like this, that has 0 runoff. Okay? So that's okay. That's going to happen. One more I want to look at with you. Let's say we have this situation. 4, 7, 4, 1. Make a T-chart. 4, 7 goes there, 4, 1 goes there. This is my X, this is my Y's. Change in Y from 7 to 1. We got smaller. We went down 6. But change in X, what happens there? From 4 to 4, we didn't change at all. So we're at the slope, change in Y, which is -6, over change in X, which is 0. So now we get -6 over 0. Can we have 0 on the bottom? Is the slope 0? Those that have a calculator in front of you, if you put this in your calculator, if you go -6 divided by 0, what does your calculator tell you? says error, right? Or divide by 0 error. You can't do this. You should have learned this in elementary school. You can't divide by 0. So the slope here is what we called undefined. Okay? I just have my kids do this. We just call it und for short. Slope is undefined. You can't do it. So what do you mean you can't do it? What does that look like? Let's go back and look at this in picture form. So if I draw the graph of these right here, this means go right 4, go up 7, 1, 2, 3, 4, 5, 6, 7. So we have a point here. And then 4, 1, which means go right 4 and go up 1. We're here. So you have a point there and a point there, and I send a line through them. Huh? So here's my guy, and yep, or here's my guy up here. He's definitely going to go down 6, right? Down 6 times, but then he's going to run right or left, nothing. So here's your house. Here's your rooftop. And here comes all the snow falling in your house. Can you have a roof that looks like that? No. What's even holding your roof up in the air and all the snow's falling in your house, right? So you can't do this. This is why we call it undefined. Okay? You can have 0 on top. That means 0. That's flat. That's Arizona roof. You can do this. But you can't get 0 on the bottom. That's undefined. It looks like this. Okay? So today we went over how to find slope from a table and from 2 points. And what we used was what we called change in y over change in x. Okay, so yes, you could do the graph pictures once again and go positive, negative, 0 slope, and now we added a new one, undefined, right? Undefined. Okay? But we can simply just do, we don't need to make the picture always, we can simply just go change in y over change in x. So you have table problems today in your assignment that you need to complete, and then you'll also have problems that you'll have ordered pairs that you need to make a mini table. Alright? If you need help, reach out to Mrs. Brimhall or myself, and we'd be happy to help you.